So I had a student that I tutored a few years ago in Algebra 1 that said I had an unusual meaning to the word fun, because whenever we would do things in Algebra 1 that he didn't like, I would say, "Oh, this is so much fun." And that's how I feel about special right triangles. I feel like they are so much fun, but maybe not everybody enjoys my enthusiasm. First, a warm-up with some of my favorite type of geometry / algebra problems. So these are really algebra problems where we would multiply radical 2 times radical 2 is 2, and 6 times 2 is 12. Now the next is where we have to rationalize the denominator. We cannot have radical 3 bottom, so we're going to multiply the top and the bottom by radical 3. That's the same as multiplying by 1, because radical 3 over radical 3, they're the same number, so they're 1. So you get 6 radical 3. Radical 3 times radical 3 is 3. And you can simplify. This is 2, so you should get 2 radical 3. Told you I love this stuff. And then for the third problem, same way we just did it, radical 2 on top and bottom, so I get 5 radical 2 divided by 2. 5 is not divisible by 2, so you get 5 radical 2 over 2. And the last problem, I'm not sure. Obviously, you can make some sense here, but I'm not sure if we've actually learned the theorems yet to be able to do this. If this is a square, they want you to find DBC. Well, if this is a square, this is 90 degrees. So there's a theorem, but I think it actually comes up in chapter 8 when we talk about parallelograms. It tells us that the diagonal of a triangle the diagonal of a square is going to bisect, and this is also going to be an angle bisector, dB. So that would mean each of these are 45 degrees. Don't think we've actually learned that theorem yet. You probably would have guessed and gotten it right, but that is the correct answer. 45, 90-degree triangle. It's called an isosceles right triangle. You can actually, like we just did in the warm-up exercise here, when you cut that square across, you're going to get two 45, 45, 90-degree triangles. So basically, you could take each leg would be the same measure. And rather than having to do Pythagorean theorem, the side opposite the 90-degree angle, so the hypotenuse, is going to be x radical 2. Basically, you'd be doing x squared plus x squared equals some number squared. So rather than having to go through this whole Pythagorean theorem of a squared plus b squared equals c squared, where a and b in this case are going to be the same measure, you can just know that it's going to be x radical 2, meaning this, if x is 3, this is 3 radical 2. If the length of the side leg here is 4, the hypotenuse is going to be 4 radical 2. And we can use this, as I said, in some examples. So I don't have to do 8 squared plus 8 squared equals what squared? I don't have to do all of that. I just know that 8, this is going to be 8 radical 2. If you want to see that this works, 8 squared plus 8 squared, that's 64, plus 64 is 132. 132 is obviously, so the square root of 132 would be the square root of 64 times 2. The square root of 64 is 8. we would get 8 radical 2, which is what we did by using the rule for a 45, 45, 90-degree triangle without actually doing all that work. If you forget the rule, you can always use the Pythagorean theorem to solve it. Okay? So in this case, you would take 3 radical 2 and times it by radical 2. That's 3 times 2, which equals 6. That's kind of like the first problem we had in our warm-up. Okay, and now if we have the hypotenuse, we can work it backwards. So we know that 5 radical 2 is going to be equal x times radical 2. So in this case, we can actually see right away that x is going to equal 5. And this is the type of problem you would see on a test. Triangle WXY is a right triangle. Find the length of WX. So that's 25 times radical 2 is 25 radical 2. I can see that number 1, something times radical 2 is going to be 2 radical 2, so x has to be 2. I can see here, if this is radical 2 and this is radical 2, so radical 2 is the leg times radical 2 is going to be 2. And D is going to be 8 radical 2. 8 times radical 2 is 8 radical 2. Find the leg length of a 45, 45, 90-degree triangle with a hypotenuse of 6. So 6 is going to be equal to x radical 2. So in order to do this, I'm going to divide both sides by radical 2. 6 radical 2 is equal to x. And then as we had in that warm-up, erase this over here. We can't have radical 2 as a denominator. I think this was actually one of our questions in our warm-up. So now I end with 6 radical 2. Radical 2 times radical 2 is 2. And I get 3 radical 2. In Gem 6, and they just seemed so difficult, and I failed it because you all have been telling me you failed it, but it really wasn't that bad. How come it's not bad, Mrs. Falcon? It's really because you've had 2 more years of learning and allowing your brain to grow. So we did 45, 45, 90. Now we're going to do 30, 60, 90, which gets a little bit more confusing because there's more you have to remember, but you can do this. The shortest leg is obviously going to be the leg across from the 30-degree angle because it's the shortest. And this is where you've learned things. We've done hinge theorem, so now you know that has to be the shortest. The longest is going to be twice that amount, and that's going to be the side, 2x, across from the 90-degree angle, or the hypotenuse. And the one in between, if I ordered them from least to greatest, you're going to take the side opposite the 30-degree angle and multiply it by radical 3. So basically, you kind of remember x radical 3, 2x, they go in order from least to greatest, move side opposite the 30-degree angle, the side opposite the 60-degree angle, and the side opposite the 90-degree angle. They use this ratio, 1 to radical 3 to radical 2, because x is basically, there's a little invisible 1 here, so the coefficient is a 2, and you're multiplying radical 3 times your variable here, if that helps you to remember it. And now we're actually going to use this. The logo on a recycling bin represents an equilateral triangle. When you cut an equilateral triangle down the middle here, you get two 30, 60, 90 degree triangles. The length h of the altitude is approximately the height of the logo, which means if the side opposite the 30-degree angle is 3, remember this is x radical 3, and 2x. So if x is the side opposite the 30-degree angle, this is going to be 3 radical 3. If I put that into a calculator, if I find, let's actually do that, just so you can see how that works. Okay, so if I do 3 square root, that's 1.732051 approximately, times my coefficient of 3, I get that number, which is approximately 5.2 centimeters. Now they want us to find the lengths in a 30, 60, 90 degree triangle. So in this case, they first say, find the value of x. We have two variables here. They gave me the side opposite the 60 degree angle. So 9 is going to equal x radical 3. I'm just going to walk through the steps here. I divide both sides by radical 3. I get 9 radical 3. I'm multiplying that. I know they have that there, but sometimes you say it works better if I do it at the same time. Times radical 3 on the top and the bottom, because that's like multiplying by 1. So I get, as you see here, 9 times radical 3 is 9 radical 3 over 3. 9 divided by 3 is 3. The answer is 3 radical 3. Okay, and then to find y, 2 times the shorter leg. So 2 times the 3 radical 3, right there, gives you 6 radical 3. We have a word problem. The body of a dump truck is raised to empty a load of sand. How high is the 14-foot body? So that's 14 feet. From the frame, when it is tipped upward at the given angle. Okay? So the hypotenuse is 14. The 45-degree angle, okay, they got 14, length hypotenuse is 14 feet. So x radical 2 is equal to 14. I'm doing the 45-degree angle. Okay, I divide both sides by radical 2. I get x is equal to 14 divided by radical 2. So as I told you, then I'm going to multiply the top and the bottom by radical 2. I get 14 radical 2 over 2. 14 divided by 2 is 7. 7 radical 2. So square root of 2 times 7 is almost 9.9 feet above the ground, if I did that correctly. Okay? And that's about 9 feet 11 inches. Okay? Let's also look at the 30, 60, 90. Okay? And this is what I wanted to make sure I understood here. They're saying that since it's tipped 60 degrees, it's this angle. That's the angle of tippage, is 60 degrees. Okay? So the hypotenuse is 14. We want to find the side across from the 60. Okay, that means if this is 14, the shorter side is 7. That's the side opposite the 30-degree angle. We want the side opposite the 60-degree angles. They've done this here. 7 times radical 3. So square root of 3 is approximately this, times 7, is 12.12. And that makes sense because if this was tipped 45 degrees, the height was 9.9. If it's tipped 60 degrees, that's greater than 45 degrees. So this height off the ground gets 12. Okay, this first problem, I disagree with the answer. I'm saying that since your substance is x is 1, then 1 times radical 3 is radical 3, and this would be 2. This is the perfect ratio. They're saying, the book here, that x is equal to 3. So let's just see how this works here. X is equal to 3, then this is equal to 3 radical 3, and that's 6. So I really do think that there's a typo here, and that this x is 1, and 1 times radical 3 is radical 3. On number 6, okay, this is a 30, 60, 90, because it's an equilateral triangle, 4, 4, this would have been 4. So this is the 60, and this is the 30. So remember, this is x radical 3, 2x. So the 30 is 2, so this becomes 2 radical 3, and that makes sense, 2 times 4. So the answer is 2 radical 3. We agree with that one. Yay! What if, in example 6, and that was on with our dump truck, the truck was raised 30 feet above the floor. So remember, the hypotenuse was 14, but now this is 60, and this is only 30. So then half of that would be 7 feet. In a 30, 60, 90 degree triangle, describe the location of the shorter side and describe the location of the longer side. You may not be sure what they're asking for, but the shorter side is adjacent to the 60 degree angle, and the longer side is adjacent to the 30 degree angle. That's going to be important as we get into our lessons on trigonometry. They're introducing you here to the word adjacent. So x, which is across from the 30 degree angle, is adjacent to the 60 degree angle. Quiz. Find A if B is 10 radical 2. That one's pretty easy. Because these are congruent, this must be 45, 45, 90. If this is 10 radical 2, hopefully at this point you're noticing the pattern, and A would be just 10. Now find B if A is 19. 19 times radical 2 is 19 radical 2. I have to go back and forth here to look at these two. Oh, they have the drawings for us. Still, that's great. Find D and E if C is 4. So that's the shortest side, which is also the side adjacent to the 60 degree angle. So then this would be 4 radical 3, and 4 times 2 is 8. Okay, so D, 4 radical 3, E is 8. And find C and D if E is 50 radical 3. Okay, so that's the hypotenuse. I'm going to find C first. So 50 radical 3 divided by 2, or actually that's not the way we would see it now. We would actually see it as 50 radical 3 divided by 2. You guys will like that better. 25 radical 3. So C, which is the shorter side, is 25 radical 3. And then for the longer side, oh, I'm having so much fun here. You have no idea, especially after that mean geometric mean video. 25 radical 3 times radical 3 is 25 times 3, which is, you guessed it, 75. So D equals 75. Yay! I love this lesson, don't you? Ooh, one more crazy problem. Find X, Y, and Z. Okay, X is going to be 6 is equal to whatever it is times radical 2. Divide both sides by radical 2. And you get 6, oops, hold on a second. Thank you for calling during the movie. Do you know how to divide by radical 2? Okay, so you multiply the top and the bottom both by radical 2. You get 6 radical 2. Radical 2 times radical 2. You have any idea what that is? Radical 2 times radical 2. So square root of 2 times the square root of 2 is just 2. Or it would have been the square root of 4, you're right. The caller on the phone said 4, so the square root of 4, which would be 2. Now you have 6 radical 2 divided by 2. So what's 6 divided by 2? You got it. So the answer is 3 radical 2. See, you could have been in geometry. And hold on, I know. I can call you back in a few minutes and tell you. Go back to sleep, Ryan, my love. I hope you all enjoyed. That was Ryan calling me from his room while I make this video. I pulled that away too soon. So X is 3 radical 2. We saw that. Okay? Now, I'm going to find Y and Z. Okay? So this is the same here. So this is 3 radical 2. That's the side across from the 30. So to get Z, that's 3 radical 2 times 2. So Z is 6 radical 2. And to get the 60, I'm going to take 3 radical 2 times it by radical 3, which is going to give me 3 radical 6. Oops, what happened? Oh my goodness, now I'm getting all kinds of things. And I got that 3 radical 6 for Y and 6 radical 2 for Z. I love this lesson. Here are your pages for homework. And you even got to listen to me teach Ryan a little bit.